to create a fully photonic computer, there would be a few problems you'd have to run into, such as the first problem is, would you add logic gates or not? Because now in photonic chips we're using analog computing, which is using every value essentially. And this allows you to do math extremely quick. But we're doing math really quick and processing extremely quick. This abuses native computing with the analog computing. But with analog computing still and these photonic chips, so I would even have logic gates. Because we made them in the first place because of this little thing called binary. Binary only uses two values, 1 and 0. And with those two values come a question. How could we compute something and render games such as even Minecraft? It's actually very CPU heavy. How would we even render it without having to wait like 5 years just to load one frame? That was a question, and now we figured it out with using logic gates. A such thing that use different connections between transistors to create logic out of just two values, which is extremely important. The reason now is debating whether we should use logic gates or not, because that is an immediate question. Since we can think about this. I would say maybe, as long as we advance logic gates. If we do not use logic gates, then we lose our whole understanding about how computers work, to say. And what we're doing is we're just debating what to do. And this could make or break computing forever, as if a large company which has large influence over people decide to use this thing, and this thing, it could change the course of history forever. Either it advances civilization or it doesn't. It depends. But I'm not the first one to think about creating photonic chips. It's actually been made like 5 years ago, which is pretty late for me. So that begs the question, do they use logic gates? No. From what I see, QAnt, the company which is most famous for the photonic chips and actually only makes photonic chips, has an NPU that's actually in a German supercomputer, but is trying to be used in AI data centers. It does not use logic gates, and instead it uses the wavelength interferences, allowing them to interfere and do math by themselves as it cancels out. I believe it makes a difference, so that means it does subtraction. But this would be good, because we can run extremely quick calculations and make them at more than at one time. But now, this thing still. If I'm certainly creating a company where we create photonic chips and everything, and create the future, add the quotation marks, we need to think what would be the best way to improve human society, and this comes with knowing a lot about the economy. I myself am not that good at it, but I am okay at it, I could say. I have been debating a lot of stuff actually, and have figured out many things just from debating it to myself. And that has been pretty good, so that could help. And I've actually been saying, let's say if you try to create your own government type of thing, which the government follows, it won't be as good as such capitalism or communism, because some people think when they see these glorious thing that they put up, it might be good for them. It only matters, and since it has a giant influence currently, that makes it better for people, because they can't just go and not and pick it up, and you can't just create a country out here. First of all, other countries would probably try and attack you and try and get your land. If you somehow manage to get land that's not in another country and not owned by a country, or if you buy the land from a country, and I would not recommend making a war with that country. If you even can get a military, and this is why it's horrible to create countries now, which doesn't prove. So there are two types of things, and influence depends on one singular thing. So ride or die, even if you use CIA tactics, like you can see, still, it won't matter essentially, because at a point people just can't get out of it. It's nearly impossible for some people. But still, taking this into action, you would need influence to do this, because rising tech companies such as Qwant and other companies like Lightgen from China, focusing on photonic chips, would probably get famous before you could. And this would be a problem, because if they decide not to use logic gates and you decide to, that would be horrible for you. And this would be a downside for you. Such they're larger and they have a bigger influence. You need to be able to do this quick or make the decisions such as. But now, let's say we used advanced logic gates. We'll have to find a way to separate everything and not take 5 billion years to do everything. So this is why I would decide to sometimes use logic gates and sometimes not. It's a 50-50 almost, or a 30-70, or a 40-60, or something like that between. And this would make a great deal of things. And this could help you. You can process fast, but also do complex tasks quickly. And this could lead to something good. So, if you see something, if there are two architectures, two main architectures currently. There's ARM, x86, and x64. There's three, but what I mean is the architectures, quotation marks. So CISC and RISC. RISC is a whole lot different from CISC. CISC is the ones you use in your computer. And CISC is a bunch of complex instructions, while RISC is just breaking up the instructions to make it multiple instructions. And RISC architecture is on your phone currently. So, what this does is, if we have a balanced architecture, and let's assume we use this in a really old or a really bad, just a cheap chip that you could buy from like Intel, AMD, or anybody else, or off of eBay or something. If you added this architecture, this would allow you to, this would allow you to break up instructions, but also do CISC. So you could, if you're doing a really complex task that the chip cannot handle, CISC will fix this. And it will do exactly what you need. It'll break up the instructions so you can process it. And if we just have this chip and make it photonic, this would be a great advantage and a great deal to us, because processing could be handled by just using everything normally, like using photonic chips normally how they're used currently, but logic gates could severely advance it, and this would be pretty good. But let's assume you're switching from not just silicon, but ears, but anything else, and you're switching from it. This could be also a problem, because if you're far deep into designing it, that's horrible for you. You're going to have to create everything up. Now, I'm not cooketh yet, but I wrote all of that binary for nothing, so that was a shame. But, and almost all of my work was for nothing, but that's not a shame, of course. I'm actually fine with that, but I've basically barely gone into logic gate design, so this lets me process. And I can actually be able to process faster, no more ALUs and stuff. All I have to do is use a RISC/CISC architecture and just turn it into like a subtraction. It'll be easy. This would be a whole big deal. But since this is the case, I believe if you're far deep into creating the chip, just finish it for silicon, since the photonic chip market isn't big, since anything like RAM or anything else, any other thing actually, anything won't be compatible. It can be compatible using a PCIe board, I believe, but then it just slows everything down and just gets rid of the benefits. So if you're willing to create a whole photonic computer, good luck, I guess.